It looks like a 7-year-old drew it, but it was actually designed by German engineers in World War II. This is the Karl-Gerät, a 124-ton monster with a 600mm mortar that destroyed fortified bunkers, left craters 15 metres wide and 5 metres deep, and could psychologically destroy enemies. So with that kind of firepower, why did Germany only build a handful? After the devastation of World War I, Europe became obsessed with fortifications. Concrete was seen as the future of defence, and Germany entered the next war believing it would need something capable of smashing straight through them. They were wrong. World War I saw both sides stopped in their tracks. Months and months of fighting for only mere metres gained. Artillery fire would shake bunkers, but rarely destroyed them. The general consensus post-war was that an enemy that was hunkered down made any frontal assault costly and slow, with many dead for almost nothing gained. This is why the French produced the Maginot Line, a vast network of bunkers, pillboxes, gun emplacements and fortifications that mainly stretched across the eastern border of France. This was built over 9 years from 1929 to 1938 to deter a German surprise attack and eventual invasion. The Germans knew this was the case and couldn't afford the harsh stalemates from decades prior. It was against this backdrop that in 1937, years before the outbreak of hostilities, Rheinmetall, a German arms manufacturer, proposed the idea of a mobile, super heavy siege mortar, whose main purpose was to shatter enemy bunkers, in not just the Maginot Line, but any fortified positions across Europe. This wouldn't be an easy feat, however. Such a machine would be enormous, difficult to transport, and would require large, specialised crews to operate, kind of like your mother. Even in peacetime, this would take years to develop, but tensions were already rising across Europe, and it left very little time for engineers to come up with a brand new vehicle that the world had never thought would be possible. And by the time it was ready for service in 1941, Germany had realised their fears were mostly misplaced. A giant weapon, built for a war that had already moved past the hypothetical situation it was supposed to address. So how do you break through thick concrete effectively? As you can imagine, the German solution to this was to strap as much explosive filler into the largest shell they could possibly make. The Karl had a monstrous 600mm short barrel mortar that fired a few different types of shells, the largest and most exciting being the heavy concrete piercing shell. It weighed 2,170 kilograms and had 289 kilos of explosive filler. It was capable of travelling at 220 feet per second, and even with that low velocity, it would punch through 2.5 metres of concrete. Seeing this car-sized mortar flying through the air at Mach fuck towards you would be a good enough reason to retire from military service on the spot. Now, as you can imagine, being able to fire such a large shell doesn't come without its drawbacks. It's worth noting that the Karl was self-propelled. It had to move under its own power. That created a balancing act. The vehicle needed to be light enough for engines of the time to move it, while also being strong enough to not tear itself apart every time it fired. The Karl ended up weighing 124 tonnes, or about the same as 60 Holden Commodores stacked on top of one another. The power plant was either the Daimler-Benz MB503A petrol engine or the MB507C diesel engine, both being liquid-cooled 12 cylinders, each producing around 430 kilowatts with a massive displacement of 44.5 litres. For comparison, the 2025 Mercedes-AMG C63 motor is a 2-litre 4-cylinder that produces 500 kilowatts with the assistance of electric motors. Karl's motor had the same displacement as 22 of these motors while producing less power than one. The Karl had a top speed between 6 to 10 kilometers an hour. It wasn't breaking any land speed records, but it moved under its own power, which was the entire point. Being a mobile mortar was great, but the 600mm produced a tremendous amount of recoil. 680 tonnes of pressure to be exact. So engineers procured a recoil management system alongside a complex hydro-pneumatic suspension system that used engine power to push the entire hull into the ground. It literally sat down to shoot. The Karl transferred the violence of the recoil directly into the planet, using large metal pads underneath the hull to protect it from cracking. The suspension was also used to level the Karl on uneven ground. Even a slight angle to one side presented numerous problems. If you fired the Karl while it was even 3 degrees lower on one side, the shell would arc into some random bloke's house and not a bunker. It also had the potential to destroy suspension components. The recoil was designed to be pushed straight into the ground. Any angle meant axial loads being redirected into components like torsion bars, and they weren't designed to survive that. Precision wasn't an option, it was a necessity. So you have a huge movable mortar that can position itself, stop, squat, fire a Volkswagen Beetle-sized mortar. But now lies the question, how do you reload the Volkswagen Beetle back into the breach? The answer is, you don't. A Panzer IV does. 22 Panzer IVs were stripped of their turrets and modified with a superstructure that was capable of carrying 4 shells as well as a crane to load each shell onto a track. Once on the track, multiple men would have to manually lead the shell into the breach via cranks along the track. It was a slow, clunky reload that would often take up to 10 minutes per shell. That's 6 shots per hour if everything goes perfectly. But in the middle of European winter, perfect wasn't always on the table. It was often muddy and the soil was soft, which proved another large problem for the Karl. Due to its immense weight, you couldn't use the traditional clutch and brake steering system most tanks used at the time, which essentially stopped one track completely and used one to pivot the tank. If you try this in the Karl, it would throw a track or dig itself into the earth. To combat this, German engineers utilised a regenerative steering transmission. This used a complex planetary gearing system that allowed both tracks to be powered at different speeds. It could only turn on a fixed radius depending on the gear it was in. So first gear would turn sharper than the third or fourth gear. And by sharp, I mean, by the time it does a U-turn, the wall was already in another country. Even with this adopted system, the Karl still wasn't allowed to turn on soft soil, only from the fear of it throwing a track. Soft soil caused problems even while stationary. Firing in soft soil with the hull against the ground would push the Karl into the earth and act as a suction cup. It sometimes would need help just to remove itself, as the engine wouldn't provide enough power. There was no way of preventing this, it was just a natural consequence of the weight and firepower. Making the Karl effective was one problem, but getting it to the battlefield was another entirely, and that is where the real problems began. Because the Karl was so large and slow, you couldn't just drive it to the front lines. Even if you had the time, it would chew through roads, fuel, and mechanical components long before it ever fired a shot. So transport had to happen by rail, as close to the target area as the network would allow. But none of the German carriages could hold all of this weight. So a new type of Schnabel car carriage was created just for the transportation of this beast. It featured 2 main arms that suspended the chassis in the air using hydraulic props and then connected it to the base of the carriages, essentially making the Karl become a part of the carriage itself. This evenly distributed the weight across multiple axles on the carriage and made it much more forgiving on the railway. Even when it was moving across short distances under its own power, bridges became quite a real problem. The Karl needed to have auxiliary trailers that could be used to travel across bridges. It would be partially disassembled, carried across the bridge in sections, and then reassembled to drive under its own weight again. This would take hours, if not days. It wasn't efficient at all, but neither is having a bridge collapse under you. And that inefficiency didn't disappear when everything was smooth sailing. It got handed on to the crew. The Karl wasn't operated by a handful of men like an ordinary tank is. It required dozens of people, drivers, engineers, loaders, crane operators, rail crews, security detachments. and most of their time was spent doing everything except firing the mortar. The Karl itself needed 21 people just to fire one shell, and that isn't including all of the personnel required in all of its other operations. You needed a small army just to get from point A to point B. Moving the Karl wasn't just specialised railway carriages and constant disassembly. It was about whether you could even assemble the men required to operate it in the middle of the war. And the problems don't end there. A mortar this large used completely non-standard ammunition. Nothing else in the German arsenal used a 2-ton mortar. They were produced in specialised plants with specialised tools and skilled workers. If a production building or railway line was bombed, the Karl didn't just run low on ammunition, it could be taken out of service entirely for the foreseeable future. Everything above made Karl a logistical nightmare, and by the time it was entered into service, the war had already moved past the fortifications it was designed to destroy. Germany had moved around the Maginot Line instead of through it. So why did it exist? In 1940, Germany completely bypassed the Maginot Line, passing through the Ardennes forest and Belgium alongside the English Channel. The Karl, however, was still in development and wouldn't see service until the next year. Regardless, Germany continued to develop it. But why? The explanation is simple: sunk cost fallacy. Germany had already invested heavily in the Karl as a wonder weapon, that by the time they had invaded France, discontinuing development would have been a massive waste of resources and time. It was also a piece of propaganda to showcase the might of the German army. Only 7 were ordered by the time it saw combat, and only 6 of them had names. But the names themselves were fitting for such a large weapon. They were Adam, Ava, Thor, Odin, Loki, and Zeus, with the 7th never receiving a name. Although it wasn't used to attack the Maginot Line, it wasn't just a 124-ton paperweight. There are multiple cases of the Karl in combat, with 2 notable battles being in Sevastopol in 1942 and the Warsaw Uprising in 1944. Sevastopol saw Thor and Odin move up to the front lines alongside a 3rd Karl, with 72 heavy shells and 52 light shells ready to use. Their main target was the Maxim Gorky 1 fortress, attempting to destroy their 2 twin 30.5cm turrets. But the Karl mainly battered the bunkers surrounding them. One turret was destroyed and the other damaged, but not put out of service. This wasn't all the Karl's doing, however. Its big brother Dora did a lot of the hard work. According to the Soviets, the turrets ran out of ammunition and they were forced to retreat. Warsaw was different, however. It was a city fortified by the Polish resistance, trying to be recaptured by the ruthless German reign. The Karl Zeus was used to level fortified buildings and break the will of civilians and insurgents, trying to force them to surrender. Overall, the Karl did see combat, but with the heavy logistical tax and highly limited useful scenarios, the Karl did not see as much combat as originally planned by Germany. It was a symbol of military might that was wounded by complex drawbacks that weren't solved easily. In summary, the Karl was a marvel of German engineering, a 124-ton monster designed to smash fortifications. By the time it was ready, the war had already moved on, leaving it chasing a purpose that no longer existed. Moving it, manning it, and keeping it supplied required an army's worth of personnel, specialised railcars, and factories dedicated solely to its ammunition. When it did fire, the results were terrifying. Massive craters, flattened bunkers, and buildings reduced to rubble. Yet those moments were rare, limited to situations where the logistics could actually be managed. In the end, Karl-Gerät wasn't just a weapon, it was a monument to ambition and obsession. A reminder that even the most insane engineering can't bend the reality of ever-changing warfare, no matter how clever you are. Karl was a weapon that proved that bigger wasn't always better, but it sure was impressive. If you enjoyed this video and want more mechanical madness, feel free to like and subscribe. And as always, praise be to the monkey.